There are various systems out there which we'll look at in a minute, but most airline jets use the bleed air system. Hot air is ducted via the engine bleed valve from the compressor stage within the engine. The air then runs through a pre-cooler to reduce its temperature to 200 degrees, and this cooled air is then distributed via the bleed ducts to consumers like the air conditioning packs, for example, and the wing anti-ice system. The principle is very similar to your household radiator, but instead of hot water running through the pipes, hot air heats up the leading edge and melts the ice. So the hot air is then guided along the wing through these telescopic pipes into a piccolo tube, where the air is distributed through these little holes, warming up the slats, and exits via these little black holes at the end. Now the system for the engine anti-ice works very similar. The engine intake very often has this shiny alloy lookalike surface. That's the engine anti-ice area. Again, hot air is extracted via the engine anti-ice valve from the high pressure compressor stage and is piped forwards to the engine intake. The hot air is then distributed through this pipe with these little holes, heating up the intake lip and melting any accumulated ice. And once it's done, the hot air exits via this outlet right here. So why not leave the engine and wing anti-ice turned on throughout the entire flight to prevent ice from building up in the first place? The main concern, as so often, is fuel consumption. When you turn on the wing or engine anti-ice, the FADEC increases the engine's power to provide constant pressure to all other bleed air distributors, thus increasing the fuel consumption.